Hello, I am going to present very interesting solids, the Platonic solids. Firstly, I am going to present the particularities of these solids, then, I will present them to you. Next, I will tell you about their history. At the end, we will see their use. So, what is a Platonic solid? In Euclidean geometry, a Platonic solid is a polyhedron that is both regular and convex. All faces are convex regular polygons, the edges are the same. The vertices are identical and all faces are identical. There are only 5 solids which respect this conditions. The tetrahedron. It has 4 triangular faces. The cube. It has 6 square faces. The octahedron. It has 8 triangular faces. The dodecahedron. It has 12 pentagonal faces. And the icosahedron. It has 20 triangular faces. But, why are there only 5 Platonic solids? To start, each vertex of the solid must coincide with a vertex on at least 3 faces. Otherwise it is just a side point and not a vertex. At each vertex of the solid, the sum of the angles between the adjacent sides relative to the adjacent faces must be strictly less than 360 degrees, otherwise, the solid cannot be convex. The angles of all vertices of all faces of a Platonic solid are identical, so each vertex of each face must be less than 360 degrees, 3 equals 120 degrees. Regular polygons with 6 or more sides only have angles of 120 degrees or more, so the common face must be the triangle, square, or pentagon. So there can be Platonic solids with square, triangular and pentagonal faces, but the sum of the angles that meet at a vertex must now be less than 360 degrees for that the solids are convex. For the triangular faces, each vertex of a regular triangle has an angle of 60 degrees, so a shape must have 3, 4 or 5 triangles meeting at a vertex. These are respectively the tetrahedron, the octahedron and the icosahedrons. For the square faces, each vertex of a square has an angle of 90 degrees, so there is only one possible arrangement with 3 faces at one vertex, the cube. For the pentagonal faces, each vertex has an angle of 108 degrees. Again, only one arrangement, of 3 faces at one vertex is possible, the dodecahedron. Now, let's see the story of these solids. We do not have exact dates on the discovery of solids, so they are all approximate. Plato is not the first to discover these solids. A study claims that the Neolithic peoples of Scotland would have built stone models of the 5 solids at least 1,000 years before Plato, but this study is not very reliable. In the history of mathematics of ancient Greece, the following chronology can be traced. Archytas would have been the first to build the cube, in 430 BC. And Democritus would have been the first to build the tetrahedron in 400 BC. Then, the Pythagoreans had an empirical knowledge of 3 solids: the tetrahedron, the hexahedron, the dodecahedron. They would have been the first to build the dodecahedron. The Athenian mathematician Theaetetus discovered the other 2 solids around 400 BC, the octahedron and the icosahedrons. Above all, he built them first, all 5. Euclid gave a complete mathematical description of the Platonic solids in the Elements. Solids are named after Platon because they played an important role in his philosophy. He associates each of the 4 elements, earth, air, water and fire, with a regular solid. It was Aristotle who named the 5th element, ether. He considered that the universe was made of this element, and that it was substantial to all the others, that it contained them all. What are Platonic solids used for? The Platonic solids are used in meteorology and climatology to model atmospheric flows. In representation of the solar system, Kepler, a German astronomer, used them to model the heliocentric system of Copernicus in 1556. In spiritual care, especially in lithotherapy and the chakras, each solid has a different role and allows to reharmonize the chakras. In board games to make dice. 8, 12 or 20-sided dice are very used in role-playing games. Platonic solids are also findable in nature. They occur naturally in crystal structures which give the arrangement of atoms in the crystal. Many viruses also form these solids. Here are the sources of the video, do not hesitate to consult them. Thank you for listening and do not hesitate to give your opinion on this video.